Okay, so this session is all about prompting and fine-tuning models in the Microsoft Azure, basically with the Microsoft Foundry. So this agenda is quite simple. Basically, we will be discussing the fine-tuning concept. So how and why we need the fine-tuning and how we can do that with the Microsoft Azure service. That is basically the Microsoft Foundry. And I'll try to show a simple demo, but I'm not sure whether we are able to complete the fine-tuning process, but I can show you how we can do the fine-tuning, how we can start the fine-tuning process. So let's begin. So we are now in a world where generative AI is more used in all our day-to-day life, day-to-day activities. We are using the generative AI agents in our day-to-day activities, basically for doing the office works or the personal works. We are using the generative AI services. But how we can build safe and secure generative AI applications? Microsoft is offering a variety of services for building the generative AI applications and the agentic AI services. So now when I say agents, some of you may wonder what is an agent. So agent is nothing but it's an autonomous software that can do some kind of execution, some kind of reasoning, some kind of processing on data and respond to the user query. So whenever the user makes a request, the agent understand the intent and then perform the appropriate operation with the help of the tools and generate the response for the user. But the question is how we can create such kind of applications using the Microsoft tools. So we have different services available on Microsoft Azure to build generative AI solutions, basically the Copilot Studio, Microsoft Foundry, or even now you can use the GitHub models. But the today's focus is on Microsoft Foundry, the new AI Foundry portal or the AI platform for building and deploying the AI agents. But how this agents works? The basic component of an agent is the large language model because every agent is using a large language model to understand and interpret the user query. Means when the user makes a request or when he writes a prompt, the agent is using the LLM, large language model, to understand and respond. Or even if you are creating a simple chatbot, which may not be an agent-based application, still behind the scene we are using the generative AI models. It may be a model from OpenAI or Meta or Google or Microsoft or some other. There are different model providers available. So Microsoft Foundry is providing a platform for building the AI applications. If you want to build generative AI applications, you can use the Foundry portal, which gives you data, which means what you need to configure as a context data for your generative AI applications. You can manage the data with the AI Foundry. It provides a set of generative AI models. So we have a model catalog from which we can choose the appropriate model for our workload. It may be a simple model or it may be a complex model for reasoning activities. We also have the Foundry IQ, which helps us to connect the custom data to the generative AI models. Means if you want to integrate your own custom data, organization specific data, you can use the Foundry IQ. It also provides the orchestration for building multi-agent solutions. So if you are planning to create a multi-agent application or multi-agent solution, which is called workflow, you can create such multi-agent workflows using the Foundry. You can create different uh, patterns, or you can use different patterns for building multi-agent workflows. It may be a sequential, concurrent, or it may be a group chat or some other. You can create your own pattern also. And it provides observability. You can monitor the model's performance. You can evaluate the models on the Foundry portal. And trust. Finally, the trust means the security services that it offers. So Foundry, since it is completely depends on the Azure, you can see the Microsoft Entra authentication and role-based access control is enabled for the Foundry services. And also, content safety services are enabled for ensuring secure data handling on the generative AI applications. Means, suppose if the user makes a prompt, so how will ensure that the prompt is safe and secure? It does not contains any prompt injection attack. Or even if the uh, prompt is containing some kind of hate, sexual, self-harm, or violence content, how will moderate the content? How will ensure that the prompt is blocked at the user level itself? So for that, we have the content safety service, that is guardrails available. So overall, the Microsoft Foundry is providing a platform for building a safe and secure generative AI solutions on Azure. So this will give you the complete list of services and features that offered by Microsoft Foundry. So you can see the models, agents, Foundry IQ, tools, and you can also integrate various services into the Microsoft Foundry. So if you are a developer, you can still build the AI applications using the Foundry SDK, or you can use the Microsoft agent framework. And you can also see more than 1,400 pre-built connectors for connecting to the external services using the MCP, Model Context Protocol. Means suppose if you have to connect to the cognitive services, you want to connect to the database services, you want to connect to the some of the SaaS solutions, Bing or OneDrive or some other services, you can still use the connectors in Microsoft Foundry. So you can see a set of models in the model catalog. It offers models from various providers like OpenAI, Anthropic, DeepSeek, Microsoft, then Meta, Mistral, and more. So you can see all the latest OpenAI models are available in Microsoft Foundry model catalog. So I can show you the model catalog. If you go to the Microsoft Foundry models, if you go to the Discover section, and you can see here the models. So this is the new Foundry portal. So you can still go and use the old Foundry portal by switching here. But this is the new Foundry portal where you can see the models catalog. You can see all models in this section. So from various providers, you can still go and filter these models based on your requirement. So you can see some of the models are good for reasoning. Some of the models accept the image input. You can also see models which is supporting the fine tuning, function calling, streaming, and more. So you can deploy any of this model and start using these models in your applications. For example, if you want to deploy the GPT's latest model, maybe I want to use 5.2, GPT 5.2, I can use this model. So let's just click on this and deploy a new instance. See how quickly we can deploy this model. I just need to go and click to deploy a new instance of the GPT model. Done. So you can now start prompting. So you can start conversing with your generative AI model. So here you can see the model which is already there. I have some other models also available if I have to make a request. So tell me a joke about the mouse and cat. So you can see here, I'm asking some question and the model is responding. You can also deploy some image-based models. You can just go back to the models. From here also you can deploy, or you can go to the Discover section and you can search for the models, which is GPT image model. This model. So if the quota is available in this region, you are able to go and deploy this. Okay, I think this region it is not available. So I may need to go and select a different region for that. So there is a rate limiting also applied. Okay, let it be. I can go and deploy a new. Okay, I think this have to create a new project. I think this project is created in the East US location. Yes. So this location, that model is not available. So let me try some other model. GPT image 1. I can hear some people still talk. Okay, so here you can see I have deployed the GPT image 1 model, that is 1.5 is not available. So I can just go and write a prompt for generating the image. So create an image of a dog and cat playing with a ball. Let's see whether it has the sufficient quota for generating the image. Yes, you can see here, this is the image which is generated by this model. So you can see a variety of models available in the Microsoft Foundry, and based on your requirement, you can choose the appropriate model. But one thing you have to understand that these models are pre-trained models. So what is mean by a pre-trained model or a base model, you can say? So these models are pre-trained models which are already trained with millions and millions of data available on internet, which means they are already trained with a variety of data available on internet as a public data. So if you ask questions about the mathematics, or if you ask questions about the science, if you ask questions about history, if you ask questions about the films, or any questions, whatever data available on internet as a public data, it is able to answer because all these data is already fed into this model's memory. That is, it is already trained with this model with this model. So strong language understanding and reasoning across domains. So it can generate responses on various topics. So whatever question you ask, the model is able to go and give you responses. And this model can have a good reasoning skill also. Reasoning skill means the skill which is required to solve the complex problems. So in mathematics, you must have seen the reasoning questions. So like a complex multi-step processing is required for such questions. Requires long prompt and heavy prompt engineering. So this model's problem is that these models are pre-trained with the public data, but not on the private data. Means if you ask a question related to a user's personal data or the organization's personal data, it cannot answer that question. For example, suppose I have deployed a model that is GPT 5 mini, let me take. So this, I'm asking a question like, what is the reimbursement policy in Synergetics? Okay, so in our company, what is the reimbursement policy? I'm asking a question. Let's see what answer it gives. So this GPT-5 mini is a pre-trained model. We can see it is giving the answer that I'm not sure which synergetics you means because the model is not aware about the company or the company's policy data, because this company policy data is private data, that is not a public data, so it's not available on internet. Okay, so if you ask about some private data, it cannot give an answer, right? So another example what I can say, suppose if I go to maybe I have some data. So this is a Margie's travel company's data, where this is a simple description about the company. The company is offering, that is Margis Travel is the world's leading travel agency, com, com, combining international reach with the local expertise. Just tell us where you want to go. We can arrange flights, accommodation, transfers, visas, currency exchange, excursions, and all. And what are the cities they are uh, arranging or they are providing services. These are the city names, and these are some of the company information like who is the CEO, CFO, CTO, etc., etc. So now, suppose if I am going to ask a question about the Margis Travels, like what are the different services offered by Margis Travels? Let me ask a question. What are the services offered by Margis Travels? So if Margis Travel is not a public, I mean, if it is a public information available, then it will answer. Otherwise, it will just assume some information because here you can see Margis Travel is a travel agency. They assume and then providing some data. But you can see this information is not coming from our document. Means this is just a randomly generated information. So, meanwhile, do you mean specific business called Margis Travel? If so, tell me the city to share the website link or something. Meanwhile, here are the typical services that a travel agency like Margis Travel offers. So that means it is not providing the exact answer. It is just a guessing that Margis Travel is a travel agency, so that most of the travel agencies provide this services. But I know that Margis Travel is offering some specific services like this, right? So what I can do, if I want my model to give a proper answer, I have to provide this additional information with my prompt. For example, I can just copy this. Let me format this. Okay, so this so this is the information that I have. Maybe I can also copy this information. So I can keep this data and I can provide this data along with my prompt. And then I can say that, okay, then generate the answer based on this data. So what I'm doing is I'm prompting with some additional data. So inside the instructions, so I'm giving the instruction that you are an assistant that helps people to find information or that answers users' questions based on the below data. And then I can provide some data here. That is this one. So every time whenever I make a request, it is going, it is sending this information to the model and then generating the answers based on this information. So here I have already hard coded some information. Now let me go and ask, what are the services offered by Margis Travels? Now you can see it is providing the correct answer, right? If you look into this, you can see these are the different services offered by Margis Travels, right? So how it is now providing the correct answer? Because in my request, I have added this additional data. So based on this data, it is providing the answer. But you can understand that this is a hard-coded data, right? So if my organization data is very, very lengthy, then I have to provide the whole data as a grounding data. So this is called the grounding data because all my questions answers are created or generated based on this data. So I can call this as the grounding data. So providing this complete lengthy data as a grounding data is not a good approach because it consumes a lots of tokens, right? Because you can see here, even though my answer is very simple, this is just a bulleted list provided 3-4 points written, but it consumes totally 572 tokens. So that means the token consumption is very high because the number of tokens consumed in each request is more, right? Because the token consumption includes this instructions also. So providing or including this large context data in every request increase the number of tokens, and whenever the number of tokens increases, cost also increases. That's not a good approach. So now we have to think about the solution. So how we can provide the such a correct data, or how we can generate such data or such a information which is relevant and accurate, but I don't want to provide this information as hard-coded context. So this is hard-coded context data. Providing this information in every request is not a good approach. For example, if I go and ask another question like who is the CEO of Margis Travels? You can see even though it is a single line, like a 4 or 5 words are there in the answer, it consumes totally 404 tokens. So why? For a simple answer, it consumes 400 plus tokens. So that what I said, the token consumption is high if you hard code uh, the data along with the prompt. So this base models behavior is generic and not optimized for specific business tasks. This is what I just showed you. So my intention was create a simple chatbot which can answer the questions of Margis Travels, or which can answer the questions related to Margis Travels. But my model is not giving the correct answer. So I am supposed to provide some additional data along with the request every time. So this increases the token usage. You can see higher token usage, latency, and the cost per request. Best suited for exploration, prototyping, and broad use cases. So this base models or pre-built models are good. In which scenario, if you want to just explore the things, or you want to see, okay, how the Gen AI models works, or some generic use cases, some summarization, storytelling, or creating images, or creating a letter, drafting a letter. This kind of scenarios, generic use cases, this is good, but this is not good. Means the base models or pre-trained models are not good in specific business use cases. Then what we can do? Then we can go with the fine-tuned models. So what is this fine-tuned models? Models which are specially trained on domain-specific data. So this is adapted using domain-specific and task-specific data. So we will retrain the model, or we will customize the models with some domain specific data. This learns preferred style, terminology, and workflows. So while training the model with our own domain specific data, we can. Hello, hello. So those who are not speaking, please be on mute. Hello, Shubh. So here when we train this model, we can train the model to follow some style or to use some specific terminologies, okay, or follow some specific patterns while answering the questions. It requires shorter prompt with a more consistent output. You can see if I'm using a pre-trained model, sorry, if I'm using a fine-tuned model, I don't need to provide the lengthier prompt. So here in this example, since I am using a pre-trained model, so I have to provide this additional information in every request. That means it increases the token usage. But when you use a pre-trained, sorry, fine-tuned model, you don't need to provide this additional data. That is, simple shorter prompt is enough, which can give you the consistent response. Improve accuracy, reliability, and instruction adherence. Lower latency and cost due to the reduced token usage. As I mentioned, since the fine-tuned models are specifically trained on the domain-specific data, we don't need to provide additional informations in every request. So the token usage is less. So obviously it reduce the latency and reduce the cost. This is ideal for production workloads and repeatable business tasks. So very good in some domain specific use cases. But we also have an alternate option. Okay, that is called a RAG. What is a RAG? RAG is retrieval augmented generation. Means instead of hard coding the information inside this prompt, we can also use an alternate method called a RAG, retrieval augmented generation, where we will be using a knowledge base or knowledge store to refer the information. Means whenever you ask a question, the model is not going to immediately give the answer. Instead, the model will refer a data source, search and find the matching answers, and then generate the answers based on that search result. So this combines a base or fine-tuned model with the external knowledge retrieval. Means we can use either a fine-tuned model for more accuracy, or we can use a base model. And what it does, it will retrieve, the model retrieves the relevant information at runtime and grounds it response on that data. Means instead of hard coding the data along with the prompt, it will dynamically, means at runtime, it will go and search the database, find the matching answers, and then generate the final response based on that. So let me show you the same process or same data with a RAG. So I'm going to use you. I'm giving an instruction like you are an AI assistant that answers users' questions based on the knowledge store data. Okay, or I can say, okay, that's fine. Now, what I can do is I can create a knowledge store here, or I can upload a simple file. This will work like a knowledge store. So I can create a new index. Okay, this is the vector index. So here I can upload that same file. You can see this is the Margis travels file which I have used. Same file I am uploading as a data source. So this vector index name, I can give the name as Margis vector data and attach. Okay, so you can see here now I have connected the vector data store into the application. Now I'm not using any additional information in my instruction or in the prompt. Now let me go and ask these questions. So let me ask the same question. Who is the CEO of Margis Travels? You can see it still gives the correct answer. And it is saying that the answer is generated based on this PDF data. You can see here from this PDF, it has generated the response. That means it used the file search tool, or it used the file search concept, means it is using this as a knowledge base. So it create a vector store. So whenever a user makes a query, it goes to the vector store, search the data, and generate the response. So I can even ask the previous question like, what are the services offered by Margis Travels? So you can see it is providing this correct answer, right? But you can see this uh, it is generating this answer correctly, but I'm not hard coding any information in my prompt. That means there is no need to hard code the data inside your prompt. So that is the RAG concept. The concept behind the RAG is this one. We will create a vector data store, and then we will search and find the matching answers from this vector store, and the model is going to generate the final answers based on the search result. So we can see how it works. User query is received, then relevant documents are retrieved from the external data store, that is a vector database. Then retrieved context, that is the search result, is injected into the prompt. So it is dynamically injected into the prompt, and the model generates a response grounded in retrieved content. That means we don't need to hard code the context data. It will dynamically search and find the matching data, and then generate the responses based on that. So compared to the previous approach, like hard coding the context, this is much easier because it will dynamically search and find the relevant information, and then provide the answers based on that. But there are some disadvantages for this approach also. So what are the disadvantages? Limited source scope. So we can connect, or we are connecting only limited data sources there. So what are the files we have configured, or what are the data sources we have configured? Only that is referred for answering the questions. Fragmented understanding. So it is not having the complete context data. So when the search is happening, if the search result is generating only some pieces of data, then it will respond based on that fragmented data. Okay, it may not be a complete understanding. Retrieval dependency. So the responses quality is always depends on the retrieval process. Retrieval means the search process. So if the search operation is not retrieving the complete information from the database, model cannot generate complete response, because the response is always generated based on the search result. And complexity. So this is little complex to configure. If you're this using the Foundry, it is very easy. You just need to upload the file. But by code, if you want to implement, you have to create a database, you have to create an index, you have to vectorize the data using the embeddings models and store it, and then connect to the vector store to the application make a search in every request, the search result need to be combined with the prompt and then make a request. So like this, there is some complexity behind the scene for implementing the RAG. Inconsistency risk, because the quality of the responses completely depends on the search result. So we cannot predict that it will always, or we cannot anticipate that it is giving or it will give you the correct answer every time. So sometimes it may give you some incorrect answer if the search result is incorrect. Okay. And adaptability limitations. So inside your application, you have to select the appropriate databases. So some of the databases, some of the embeddings models may not be compatible with your solution, because if you select the embeddings model, there is a concept called a number of vector dimensions. So that if the dimensions are not matching, then it will not support the models. So there are a lot of compatibility issues behind the scene. So that is a problem of the RAG. But if you can implement the RAG, this will a simplest, or this is an easiest way to answer the questions dynamically based on the custom user data, right? So this is what I have just showed you. So we have three options. Either you can hard code the information inside the prompt. So every time when you make a request, the hard coded information will go to the model. Model is going to generate the answers. Or you can fine tune a model, means you can take a base model, retrain the model and generate retrain the model with your own custom data and generate the responses based on the retrained model. Or you can use the RAG, that is retrieval augmented generation, which is going to use a vector database as a reference data source. So whenever the query comes, it will search the vector database and find the matching answer and then generates the responses. Now, since our talking point is fine tuning, let's understand what or why fine tune, why we have to do the fine tuning of the models. The fine tuning improves the quality. So we can retrain the models on domain specific data. So if you use a base model or a pre-trained model, it is not specific to the industry or specific to the domain. Suppose if I have to use a generative AI model for my uh, hospital or for my legal firm, the model is not specifically designed for that. The model is a generic model which can provide you some health information, but it is not specifically designed for healthcare industry. Similarly, legal firms. So when you use fine tuning concept, we can customize the model. Fine tuning is a process of customizing, right? So we can customize the models by retraining the models with our own custom data. So what is the benefit? We can create some models that can be task specific. So this model is specifically designed for this purpose. So we can say that, okay, this model is specifically designed for this purpose because the model is trained with that particular data. Reduce the cost, reduce the token consumption. Since the prompt is containing only the query, not the context data, because context data is in the memory, because the model is already trained or model is trained with the custom information and model remember all informations in the memory. So we don't need to send anything in the prompt every time. So the number of tokens consumption or number of tokens usage is very less and efficient resource utilization. So we don't need to use a very heavy compute or anything to run these models. Model will run in the normal environment, but it can provide you some domain specific information. Reduce the latency, smaller models and faster response. So we don't need to use a very large models like you can see in our models catalog. We have models like nano models, mini models, etc. and even large sized models. So if you look here, we have GPT, GPT models. So this is GPT 5.2, this is GPT 5.1, and this is the 5.1 mini. There is a mini models. This is 4.40 mini. So you can also see the nano models. Okay, GPT 5 nano. So these are small sized models. So we have large sized models as well as small sized models. So what is the benefit of fine tuning is anyway our purpose is to use the Gen AI models on a particular domain. So domain specific data is very limited. Okay, it's not like the whole internet data we have to use. No, we are referring only the domain specific data. So the data is small. Then why we have to go and use a very large sized model? So we can use a small model. So small model means which will be faster because it is not going to use the large context, right? So that is, it says smaller models and faster response, shorter prompt and improve the response. So we don't need to write a very complex and lengthy prompt. Only the query is enough and it will give you the better response. So now developers have multiple options for using this generative AI models. Either they can use the out of the box models, which are pre-built models provided by the vendors. Okay, so around 29% of developers uses this. Or we can also use the fine-tuned models. Means around 48% of the developers uses fine-tuned model because developers are creating generative AI applications that are specific to the domain or that are specifically dealing with the organization data. Okay, yeah, just a minute. Okay. So the third option is we can create our own models. Means we can build or and train our own custom models. So in very rarely or in limited cases only we will go with this because this is more complex and expensive option. So training the model from the scratch is very uh, limited, but people can fine tune the model, which means take an existing model and then customize it. That is the best option. That's why more people follows this approach. Now, how they are building the foundation models or the base models or also called the pre-trained models. So you can see here, we will have some unsupervised data, okay, or some pre-training data. So this is a very large amount of data we have, massive amount of generic data, which is unlabeled. So that is what you can see here. This is the massive amount of data which is collected from internet on various topics. And then we will do supervise the fine tuning. That means instruction tuning we will do. We will create a data set. This is the instruction response data. That means there will be instruction and a response. Then it may be a task specific data or the and other annotated data. So we'll prepare the data set from the generic data and then do the training. We can also do the alignment, means domain specific data alignment, means if you have to create a foundation model, we can also go with the reinforcement learning using human feedback. So the models can collect the feedback from the user and then retrain to create a appropriate response. So here we can use the human preference data, or we can follow a reward model data. Reward model means whenever the model generates a response, there is a reward function which is verifying the data, and if the data is generated or the response is correct, then it can give a reward, otherwise a penalty. So we will train this model and then create a generic LLM. So we train the models on the vast generic data and then create a generic LLM or SLM. SLM means small language models, or we create a large language models. But when it comes to fine tuning, what we do, fine tuning means we are not creating the model from the scratch. Instead, we will take an existing model. So this is a generic LLM, which is a pre-trained model we can take, and then we will do training on this model. Means we do additional training on that using our own task specific data. So this is our own custom data. So we have a data set to be created, and then we will train this model, this existing model, to update its knowledge with the domain specific data. So if we have this model, okay, so we are going to train this model by rearranging its data parameters or the values. So we will be updating this model to include or to uh, uh, train with our own custom data. Again, we can also use the human feedback, that is a reward model, which may be a reinforcement learning approach can be implemented. So we will do a supervised fine tuning or reinforcement learning for the model. So supervised fine tuning means it is just we will provide a key or question and the answer, a question and answer. So it is just to remember the answer for this question. That's it. There is no reward or nothing like that. So it is just a study the question and answers. That's it. So whenever the user asks this question, it is just to answer this. Okay. So supervised fine tuning means we will have this answer provided with every question. But in reinforcement learning, what it does, it is generating a response based on the prompt provided, and there is a reward function which verifies whether the generated answer is correct or not. If it is correct, it will get a reward. Okay, so that the model understands that it is a correct one. So there are multiple approaches for doing the fine tuning. So supervised or reinforcement fine tuning. So whatever way you use, you will be customizing the existing model and creates a fine-tuned model. So you can create a fine-tuned model that is adapted with your own data or your own custom data. So then now this model which is generated is having the domain specific knowledge. How does the fine tuning works? So what we have to do, we have to first identify what is our requirement. So decide vision and scope. So what is our purpose or what is our requirement? We need to identify what is the requirement and where we are going to implement this. Then next step is we have to select an appropriate base model, because I said in fine tuning we are not creating the model from the scratch. We select an existing model and then do the fine tuning. So we can choose an appropriate model. Maybe if I'm using the model in a domain or in an industry where more complex operations are performed. So we need to select a model which can handle more complex scenarios, like a reasoning models we can select. Okay. So you have to choose the appropriate model from the appropriate vendor. Then we also need to select the appropriate fine tuning technique, whether it can be supervised or reinforcement. Okay. Or the DPO. So whatever is the fine tuning technique, we can choose that approach, or we can go with the and also we can select the appropriate model. So we select a model here and we will select the training approach here. Then we will create a data set, because depends on what is the training techniques we are choosing. Accordingly, we have to prepare the data set. Okay. For example, if you are going with the supervised fine tuning, I can show you a sample data set. Okay, so these are the approaches: supervised fine tuning, direct preference optimization, and the reinforcement fine tuning. So in the supervised fine tuning, what does it do? It's a foundation technique that trains the model on input output pair. That means for every question, there is a corresponding output configured. So that means the model is just a remember what is the answer. Okay. So teaching it to produce desired responses or for specific input. So whatever question you provide, according to the question, it will provide the appropriate answer. So this is best for most of the use cases, including domain specialization, task performance, style and tone, etc., etc. Okay. So this is supported by these models like GPT 4.0, 4.0 Mini, 4.1, 4.1 Mini, Nano, Llama, etc., etc. Direct preference optimization means when you prepare the data set, you will create a question along with the multiple answers, and there will be one preferred answer and multiple non-preferred answer. So the scenario is, suppose one question can be relevant for some scenario. I mean, some answer will be relevant in that scenario. Some other answer will be suitable for some other scenario. So it depends on the context and scenario. Some questions answers may vary. Okay, for example, uh, if I ask a question like what is Venus? So what is Venus? If I'm asking a question, Venus can be a goddess in the Greek mythology, or Venus can be a planet, right? So depends on the context, the answer may vary. So when you prepare the answer set, suppose if I am uh, creating this model, or if I'm doing fine tuning this model to use that inside history research or mythology research application or something, then the relevant context is what? The Venus will be a goddess in the Greek mythology or something, right? So when you prepare the answer set, there will be a question like what is Venus? And there will be a preferred answer that Venus is a goddess in the Greek mythology. And there is a non-preferred answer, which is Venus is a planet, right? So that in the data set, you will provide a preferred and a non-preferred answers. Reinforcement fine-tuning. It uses reinforcement learning to optimize models based on the reward signals, allowing for more complex optimization objectives. So that means you have to provide a question, and the model is generating a response, and then a reward function is going to evaluate the answer and giving you a reward. Like for correct answers, it will give you 0.5 or 1, or for wrong answers, it will give you 0. So like this, a reward will be provided. And you can see this is supported by O4 mini model. Okay, this training is supported by O4 mini model only, but most of the models support which one? Supervised fine tuning, and direct preference is supported by these models. And you can also see some, I think, somewhere this data set example was there. Okay, so here you can see in direct preference, you can see the data set looks like this. There will be an input, that is the user prompt, and there is a preferred output as well as non-preferred output. Okay, that means you will be providing a preferred output based on the context. Maybe the same question may have two answers. Okay, in one context, this is the relevant answer. In another context, the other one is the relevant answer. So you provide the information, the context and the prompt here in the input. And for that, this is the preferred answer and not this one. So in another scenario, this will be the preferred answer and this is not the preferred answer. So that is what we give in the direct preference optimization. But in case of supervised fine tuning, we are just providing the data set like questions and answers. That's it. So here, okay, here you can see in the reinforcement fine tuning. So this is our example data set, that this is the input message and this is the solution. And once the answer is generated by this model, there is a grader. So you can see grader provide the reward function used during the training and have access to user supplied fields in the data set. Okay, so you can select a grader or you can use a grader to reward this model. So based on what kind of reward function you are using, accordingly the grading or reward process will change. So it will be basically providing a numeric value like 0 for the wrong answers, 1 for the correct answers, like that. Okay, this is a simple function. You can also see supervised fine tuning in Foundry. Yeah, so this is a simple supervised fine tuning where you can see the message, system message, as well as the user message is the user prompt, and there is a response. So this is just a question and answer pair will be there. So in this is a data set which is in the JSON-L format, so which is mostly used in the supervised fine tuning. But in reinforcement, you will be use a different data set. Direct preference optimization, you will be using a different data set. That's the reason here, after choosing the fine tuning technique, we are preparing the data set according to the technique what is selected. Then we do the fine tuning. Then we evaluate this model with another data set. So we are supposed to prepare two data set basically. One data set is used for the training and another data set we can use for the evaluation purpose. Okay. And once you have evaluated the model and identified that the model is generating the responses correctly, we can deploy the model. Suppose if the model is not generating the responses accurately, again you can go and create more data set and retrain the model, means fine tune the model again, then evaluate and then deploy. So you can continue this process until this model generates the correct response. Means you when you get a what uh, response rate of maybe out of 10 if 7.5 or 8 or something. I'm just giving a number. So until you are satisfied with the responses generated by the model, you can continue this process. So here is a simple fine tuning process. So for that, we can in uh, Azure AI Foundry, we can do the fine tuning. Okay, means we can uh, take a base model, select a fine tuning technique, and start providing the data and then train the model, evaluate, and then deploy. But for doing this, we should have the appropriate data available. So generating the data in this particular format is very, very difficult. So because we have to prepare the data in that JSON-L format, right? So we preferably use a synthetic data generation feature available in AI Foundry. So in AI Foundry, we have the synthetic data generation feature, which means we can provide a reference data or reference file. Based on that, it will generate the data set for you. So here, if you go to the build, here is the data section. And here you can see a synthetic data generation section. So here you can go and you can see I have already generated two data sets. Let me delete this. So this is the one which I have already generated, but generation of this is very simple. You can click on this button, generate data, and here you can specify what is the task type, a simple question and answering or tool usage. So this is basically for the agents development. So we can go with the simple question and answer, and question type will be short question or long question. So short answer or long answer. So you can go with the both if you are expecting both type of answers, or you can go with a simple short answer. It's up to you. Then you can add a reference file, means you want to generate the data set based on which content. Suppose if I have to create the training data set based on the Margie's data, Margie's training, sorry, Margie's travels data, then I can choose the Margie's file as a reference file. So I'll select this file as a reference file. Then I can decide how many questions, maximum number of samples. So how many questions I have to generate. I can choose that. Okay, so here I'm giving maximum 100, so you can go with more also. Okay, so more means training will take more time. So I'll just give a maximum 100, or you can generate maybe 50. That is also fine. Then generator model, because it is generating the questions and their answers, means the data set, synthetic data generation we are going to do. So using which Gen AI model we are going to generate it. So this file will be used as a reference for generating that synthetic data. So I can use any model, maybe GPT 4.1. Okay, I can use this model. Okay, I think this model is not available in this region. Let's go with the GPT-4o. GPT-4o is also not available. I think this is also not available. Okay, then let's go with the GPT-5. Okay, that's available. Then here, split the data into training and validation set. I said, whenever you uh, do the fine tuning, we need a two data set. One is for the training purpose and another one is for the evaluation purpose, right? That is validation. So you can split the data into two pieces. Okay. So one for training and one for validation. So if you want, you can do that, and then you can provide a output file name. So here you can give maybe Margie's uh, synthetic data, or Margie's training data, whatever name you likes you can give. So now this model will go and generate the questions based on that file. So here I already have this generated. So here you can see this is what the process completed, and here is the training file generated. So this is a preview. I can show you this. If I open this, okay, this is the data. So you can see this is the first one, this is the second, I think it is 10, 15, 30. 30 records generated. You can see here, this is the content. You are a helpful assistant. You will be presented question with the clear answer. Which department head at Margie's Travel is most likely responsible for the technology strategy? So this is generating the question, right? So which department head at Margie's Travels is most likely responsible for technology strategy? So CTO, right? So here Emma Lufsen is the CTO. So this is the answer for that. So this is generated by that model only. And this is a second question. Which specialist destination listed is located in United Arab Emirates? That is Dubai. So in that there is a Dubai, right? So you can see this is creating the questions based on that PDF file which is provided. So this is the sample reference file. Based on that, it has created the questions. Now, if I have to do the training, so I already have this data. Okay, so okay, it's generated. So here around 30 questions, and here how many questions? 16 questions only. Okay. So now if I have to do the fine tuning, I can go to the fine tune section. So this is the fine tuning section. Okay, so I have started one fine tuning at 3:34 and is still going on. You can see. So it's a lengthy process. Anyway, so if I have to do a fine tuning, I can click on this fine tune button. Right. Okay. So here I can select a model. So which model you want to use, that you can select from here. I said there are different models for different purposes, you can see, right? It means which is supported. Like these models are supporting supervise the fine tuning. These models supports direct preference optimization, and reinforcement learning is supported for O4 mini. So here I can select the models from here, like the O4 mini. If I'm selecting the O4 mini, so here you can see that is supporting the reinforcement learning, okay, or reinforcement fine tuning. Suppose if I select some other models like a 4.1 mini, then it is supporting supervised and a direct preference optimization, because 4.1 mini, this one, is supporting direct preference as well as supervised. So that's the reason that two options available for that. So for uh, reinforcement, we have to select O4 mini only. Okay. So anyway, I have selected this particular one. Then training type is a global or developer. So developer means it is still in preview, like cost-effective manner, which is not for uh, a production grade application, for dev and test scenario, you can say. So I'll selected global, and here training, you can select a data source. Means if you have to train the model, you have to specify the training data set, right? So you can, we already have the data set available in our Foundry itself. So I can go with the existing data set, or if I have the data set file available in my machine, it's as a downloaded file, I can upload it. I can upload this data set. Okay. So I will go with an existing data set. So here it shows the one. So you can see this is the one. So here there are two files you can see. One is the training file and the validation file. So total number of questions divided into two parts. So this is the Margis synthetic data for training, and this is Margis synthetic data for validation. Because you remember, I have divided the data into two, that is training and validation. So I can select the training. Then for validation, I can select existing data set. From here, I can select the validation data set. Then I can say automatically deploy the model after job completion. So if you want to deploy, okay. So you can see this is the training data and this is the validation data. So now I can, if you want, you can also configure some of the additional parameters. Just a minute. Okay. So you can also configure the hyperparameter tuning and then submit the task. Suppose if you submit this task, it will start doing the fine tuning. So I'm not doing that because I already started and that is still not completed. It's more than 1.5 hour. You can see it started at 3:24, but still not completed. Okay. So you can see here, this is what. So it will complete the training process maybe in some time, but yes, we have to wait until this completes if you want to use this model. Otherwise, I can cancel this process also. So let's wait. Let's see whether it will finish or not. So we can go back. So that is what we, or that is how we do the fine tuning in Azure AI Foundry. So we can see that fine tuning is now very easy to do with Azure AI Foundry. So in AI Foundry, you can uh, use the synthetic training data. Even if you don't have the data set with you, no problem. You can still go and create the data set using the synthetic data generation feature. Train for less, 50% discount with a dev training tier and a higher quota. So if you are training for dev and test scenarios, you can use the uh, dev training tier. So I have showed you that there is a global and a developer option is there. So you can use that if you want to create a dev and test scenario only. There are different open source models available, right? So if you prefer to use open source models rather than GPT or OpenAI models, you can still go and use the open source models, because I have showed you the list of models that is available for fine tuning. Then agentic reinforcement fine tuning, fine tune for tool use in the chain thought for O4 mini and GPT-5. So if you want to fine tune for the agentic usages, that is for tool usages, then you can use the agentic reinforcement fine tuning approach. That is basically the O4 mini is supported. Now you can see a comparison chart of supervised versus reinforcement fine tuning. So we have already discussed these points, but yes, here a couple of more points on the supervised and reinforcement fine tuning. So use case. So in supervised fine tuning, inject domain knowledge and mimic style. What is this inject domain knowledge and mimic style? Here the data set is just a question and the answer, which means whenever the user asks a question, it will give you the corresponding answer. That's it. Means whatever is the answer provided, it will give the exact answer or generate a similar answer from that. Means it words and sentences may be different, but it is just creating an answer based on the given one. That's called the mimic the style. But reinforcement fine tuning, it's add reasoning, tool use, and planning, etc. So this is used for more complex scenarios where we have to think, where the reasoning logic is required. So we add reasoning, tool usages in agents, and for planning purposes, it's better to use which approach? Reinforcement fine tuning, because in that scenario only, okay, whenever you prepare a plan, okay, whether the next step is correct or not. So based on the previous step, it will create a next step. So then the grader or the function which is giving the reward, it will tell you, okay, this step is relevant or not relevant. Means it will give a reward point or not. So accordingly, for reasoning purposes, this reinforcement fine tuning is the better option. GPU usage, supervised fine tuning is consuming less because it is just a direct answer process. So you ask a question, it is just to answer your question. But if you look at the reinforcement fine tuning, it consumes more GPU power because there is a planning process happens. For every question, it will identify what is the next. Then based on that, it will give a suggestion. Then the grader will rate it. Okay, whether this is correct or not correct. Based on that, the reward point is provided, right? So it consumes more GPU. GPU utilization is higher. For data, for supervised fine tuning, we should have a very large data set required, because it is not thinking and answering. It is just generating the answer based on the given. So if there are 1,000 questions and answers provided, it will just answer for that 1,000 question. It is not thinking more and not answering. If there are 1 lakh questions and answers provided, it is just to work on that 1 lakh questions and answers, no thinking. But in reinforcement fine tuning, the data set which is required is very less. Means because if you give 100 questions, okay, then it will think this in 100 different ways. So 100 with its multipliers. So there are different other ways it can think. Okay. But in data format is also different. As I showed you, they supervise the fine tuning. It is just a question and answer only. But in reinforcement fine tuning, there will be a reward concept included. So reward concept is not there in supervised fine tuning, but in reinforcement fine tuning, it use a grader function. So based on the answer generated, it will give a reward point. Here you can see it is giving a reward point. So reward plus equal to the LLM response. If it is equal to correct answer, then 0.5. Otherwise, 0. Then training is cross entropy loss to mimic expected responses. So it will just give you the mimicked answer, means whatever answer is provided in the data set, it is just providing you that answer. So it may be a right or wrong. That's it. Okay. But reinforcement algorithms like PPO, GRPO, etc., to maximize the reward. So that is a reward points mechanisms that is used in the reinforcement fine tuning. When to choose reinforcement fine tuning over supervised? Reinforcement fine tuning generalizes the better compared when the test data diverge from training distribution. So we cannot expect that the user will go and ask the same question. So the model should have the thinking capability to generate diverse answers, right? So in supervised fine tuning, what is the problem? Whatever is there in the data set, only that is provided as the answers. It don't have the thinking skill. Okay, suppose if like in students, you can understand if there is a student who is just studying only the text content. So if there is something asked out of the syllabus or out of the text, but using the logics of the topic in the text, for example, in mathematics, that maybe the teacher has given 10-15 problems and the student is learning that 10-15 problems and he or she know how to solve that 10-15 problems and she can answer that, no problem. But during the exam, we cannot expect that the same question will be asked. The same pattern or maybe some different pattern will be asked. So it may not be the exact question. Maybe the values will be different. Maybe suppose x plus y equal to z. In this case, the teacher will be teaching the x plus y and finding the value of z. Okay. So there will be 10-15 exercises the teacher is giving and the student is able to complete the x plus y and finding the value of z. But during the exam, it may be asking in a different way. So it will be giving x plus question mark equal to z. So now the x and z is given. Now we have to find the y value. So the problem is that the student who is just learning x plus y and finding the z may not be able to solve this problem because he know only that approach. But in the during the exam, it is asking in a different way. It is giving x plus some question mark equal to then z. So now the answer is given. We have to find the value of y. So in scenarios where the training data set and the actual user question is different, then which is the better option? Reinforcement, because Supervised is capable to answer whatever is in the data set. If something out of the data set is asked, or if some different approach or different way it is asked, it may not be able to answer. Right. So that is what it's given here. Okay. So that means here the picture says, so during the training we are talking about the dog, but in the real world or in the real scenario, it may be asking about a cat. So it cannot answer that, right? But in reinforcement, even if you are learning about the dog during the training, if there is a question comes related to the cat, it is still able to go and answer that. That's just an example given. Okay. This handles complex multi-turn reasoning task that reinforcement fine-tuning excels in like with the agents. So in agentic AI applications, you can understand mostly thinking skill is more important because it's not just like a chatbot, just asking a question and giving the answer. So it has to think, okay, which is the better option? Okay, what I have to do next? So it have to think and answer. So this kind of scenarios using reinforcement is the better option because supervised is always giving you the hard-coded answers. Okay, based on the given answers, it will generate the final answer. That's it. So self-thinking is not there in supervised fine-tuning. So that is there in the reinforcement fine-tuning. Suited for agentic use. So because this is capable for handling complex operations and multi-turn reasoning, this is suitable for the agent-based development. Means if you are developing agentic AI applications for tool selection and planning, this will be the better model. Means fine-tuned models are better. Which models, reinforced fine-tuned models are better than supervised fine-tuned models? Data efficient. Reinforced fine-tuned requires 10 to 100 less data compared to supervised fine-tuned to achieve the good results. Because as I said, the supervised fine-tuning is just mimicking the given answers. Whatever data set available, just provide the answers only from that set. If out of syllabus comes, it cannot answer. But reinforcement fine-tuning is capable to generate the answers based on the given data set, but it can go and generate other answers also. Understanding reinforcement fine-tuning. So basically, this is just an example. So here the prompt is send it to the model like what is x? So x plus 5 equal to 0. Then the model will think and then generate responses like a multiple responses will be generated. And the grader is identifying which is the correct one. So like a 0, 0.5 and 1. So it is understanding that the 1, this may be the correct answer. Okay, so here x value can be minus 5, right? That's because here what is the what to do? So how you'll do that? X is equal to minus 5. So minus 5 plus 5 equal to 0, right? So minus 5 is the correct answer. So this is not at all a correct answer. This is maybe half correct or maybe even though it's at least a numeric value. Okay, so 0 point output is given. So this is not a numeric value. So X is predicted as a string value. This is not at all correct. Okay, but here at least it is predicting that it is a numeric value. Okay, X will be a numeric value. This is halfway correct. That's why the 0.5 is given. So 1 is given because it's an exact answer. Okay. So this trainer will identify from this, okay, from the generated answers, it will understand, okay, which one is the correct and then update the model. Okay, the trainer update the model weights to produce the best chain of thought. Why Azure we are using for fine tuning? So we have discussed this so far. What is models? What is AI Foundry? How the AI inside the AI Foundry, how we can make prompting, means prompt with the context data, then prompt with the RAG, and then why we have to go for the fine tuning. So what is the importance of doing fine tuning? And we saw that how we can generate the synthetic data for generating the data set for training and validation, and how to start the fine tuning process with the Azure AI Foundry. So we saw that in Azure AI Foundry, we are able to do the fine tuning. So now the question, why Azure for fine tuning? So can we do this by using the code in the local environment, or can we use some other platforms or services? Yes, we can. But why Azure? Model choice. The best models from the best providers. So Azure AI Foundry or Microsoft Foundry is providing the best models from the best providers. You can see hundreds of models available in the Microsoft AI Foundry, including OpenAI models, Microsoft models, Meta models, Google models, Anthropic models, Mistral models, then DeepSeek models, and many, many more. Choose serverless or managed compute means you can deploy the models. Means when you deploy the models, you can go with a serverless approach, which means you don't need to provision any compute. Whenever the request comes, it automatically invoke the request. But it is also possible to, to go with a managed throughput, means provisioned throughput model. What is provisioned throughput model? You can deploy a specific capacity for the models. That means every time the model will runs with a particular capacity, means dedicated instances can be used to serve the request. So serverless approach as well as managed compute is supported in Azure. Reliability. You know that most of the Azure services offers a 99.9% of high availability SLA. So even for the AI models. Latency guarantees with the PTU-M. So ensure that the latency is reduced with a high performance compute that is deployed on the cloud environment. Foundry platform, everything you need in one place, that is models, training, evaluation, deployments, metrics, everything, whatever is required for the Gen AI application development, everything is now available in the Microsoft Foundry platform. Scalability. Start with a low-cost development tier to experiment and scale with the PTU for production workloads. That means you can start with the simple models, simple tiers, even fine tuning or any process. Start with the low cost options, and then depends on your scenario, depends on your requirement, you can go and upgrade. Okay, so that it's not that you are locked into a particular tier. Anytime you can upgrade to the higher tiers. So that's why it's better to go with the Azure environment. So that's it from my side. So here, let me check whether the fine tuning process is completed or not, but I'm not sure whether it is completed. Okay, okay, I think it's completed. We can see it is completed. So we can go and deploy this model or under this models. So here I can deploy a base model. These are the pre-trained models, or this is a fine-tuned model. So click on this fine-tuned models. It's giving Why this portal is still in preview. That is why this bug's coming. Okay. Okay, let's go to the fine tune. Click on this. Here we have deploy. Okay, this is the deployment name. So I can say FT model. So here I'm deploying this new model with the name GPT 4.1 FT model and then deploy. Okay. Now let's go to the playground. Okay, I think the model is still deploying. So let's wait for the deployment to complete. So I can see a question in the chat. Will it take longer time when you add more files in the knowledge base? So for RAG, if you add more files, means longer files, yes, obviously it takes more time to vectorize and store. And also depends on your data size. The search time is also will increase. Why it is taking time? Yeah, okay, I think this is done. But still, I think it is deployment. Okay, this is the fine-tuned model. But I think, okay, okay, I think it's still not ready. Chat with model is not available. Still getting ready. We may have to wait some more time for this to complete. But you can see the fine-tuned model is listing here. Okay, by the time if you have any questions, you can post your questions here. I don't know why it's taking more time to deploy. I think it takes more time to deploy. Yes, Sunil asked a question, even if small file taking more time. So are you asking about the RAG process or the fine tuning? But fine tuning is always takes time. But again, it depends on the size, but even small files also takes time. But RAG, I don't think it takes more time. But yes, it always depends on what kind of vectorization process you used. Like you are if you are using the RAG concept, mostly it is using the internal vector storage in Foundry. Otherwise, you can use the AI search or MongoDB or some other vector storages. So it depends on the performance of your vector storage and the search criteria. The response time will change. I think it's not deployed yet. Okay, so anyway, you can see the fine tuning is completed and I am able to deploy a new instance of that model, but that deployment is still going on. It's not completed. Oh, here it is saying deployment status is failed. Reference node in the Microsoft Office. I think that deployment is failed. Training is completed, but the deployment is failed. So what is this error? Okay. So there is something internally wrong. I don't know what is it, but deployment is failed. That's why it is still rotating. But the training is completed. Okay, so we can leave that. And I have just showed you. Still, this portal is in preview only. That may be the reason some of the functionalities may not be working as expected. Here, this is still deploying only. It's not completed. Still in creating state. It's not deleting also. I don't think this will finish. This may also have the same problem. Oh, this is deployed. Who is the CEO of Margis Travels? Maybe because I have deleted this, I think. Okay, maybe it will take some time to deploy. So that's it, guys. I just tried to deploy, but deployment is taking more time. It's still creating. We may have to wait, but yes, it's time to wind up the session.